Now when you are calculating these two things, just put the value of c of t, and taking the cos twice by fct common, you can get this. After that, you should have to take the ac out of it to make ct out of it. So then you just take common ac. When you take ac a common, that will be 1, that will be am plus am divided by ac cos twice by fmt, and that is the modulation index. Am divided by ac is popularly known as the modulation index, and that is denoted by mu. In some of the books that is denoted by m also. uh, in some of the books that is mu m, some of the books that has been just denoted by m, just like that. The basic thing is that you have to remember this thing as modulation, that is carrier signal that has been added through a message signal with its phase component multiplied with it. Then that is the equation of the modulated signal. After that, you will get your answers like that. That is AC cos twice by FCT is there. You certainly get 1 plus mu cos twice by FMT, and AC cos twice by FCT plus AC mu. That's just multiply, enter to it and enter into it. You will get this AC cos twice by FT. Just multiply uh, these two terms into the bracket, and you will get that AC mu cos twice by FCT cos twice by FMT. Okay, now this part is quite isolated. Now this is the part that we have to carry on our calculation, because there are two cosine components. Whenever you have been taking whenever you are taking this kind of multiplication of two cosine parts, there is an equation of cos a plus b plus cos a minus b, that gets the equation, that gets the trigonometric equation of 2 cos a cos b. So there is an equation that we probably know, that 2 cos a cos b. What does it mean in trigonometrical function? 2 cos a cos b is equal to, if you take 2 here, you should divide it by 2. That means you have been taken the 2 here as common. Then you can get the equation done, that cos a plus b plus cos a minus b. So you get the thing here, and take the twice pi t out of it. Yes, that is the common part. Again here twice pi t, you will get the common part, and that is AC mu divided by 2. You also enter, because of you have taken out the bracket, and give as a commutative property you have distributed the distributed property, you have given the common coefficient to all of its parts. After that, there is the upper side band, that has been FC plus FM, and there is the lower side band, that is FC minus FM. So whenever you get after a plus b cos a plus b, you have get that FC plus FM right there, and there is a lower side band FC minus FM. In that sense of thing, modulation, you get the two type of things, that is upper side band and the lower side band into act. What these two things, and what are the significance of it, the upper side band, the lower side band. Now that is the amplitude modulation with respect to a frequency spectrum, or not a spectrum, that is the frequency domain analysis. In that kind of a sense, there are two kind of frequencies that has been dominant in that kind of equations, that is the carrier frequency FC, and that is the modulating frequency FM. So the upper sideband frequency is the outermost part or positive part of the bandwidth, and the lowermost part, known as the lower sideband, that is FC minus FM, that you have been that you can see here after modulation. And there is a center frequency that is known as the carrier frequency, and that is higher than the two frequencies of upper sideband and the lower sideband. Now coming back to the point of amplitude modulation. Now you can get the thing is that whenever you have been analyzing the previous not frequency spectrum, that is the bandwidth, frequency bandwidth relationship with amplitude. For this you get a certain kind of expressions like that. That is the power of amplitude modulated wave is equal to the sum of the power of the carrier, the upper sideband and the lower sideband frequency components. Whenever you are calculating the power, you should keep on your mind that where the frequency components are. So to take the total power, you have to take the carrier frequency, the USB, the upper sideband frequency, the lower sideband frequency. We know P minus V RMS square divided by R minus Vm divided by root 2 whole square divided by 2. Why that has been taken place as this. Now, first of all, what is the carrier frequency? PC. That is the largest amplitude, the maximum amplitude AC has been divided by root 2 because you have to take the RMS value out of it. Then Vrms whole square divided by the register of the circuit or register element of the circuit. You will get the power, carrier power right there. Then the USB means that's not the USB that has been used that you are using. That is upper sideband. The upper sideband is AC mu divided by 2 root 2 whole square, and the final answer is AC square mu square divided by 8R. Now you will ask me how that can become in the upper sideband region. In that context, I will make you know that there is a certain differences between the AC and AM. That should have to be AM divided by root 2. That should have to be like that, AM divided by root 2, because that is the maximum voltage or maximum amplitude of modulated signal. In that kind of context, you know AC divided by AM is equal to mu. Okay, that is the modulation index that we have learned before. AM divided by AC, that is AM divided by AC is the modulation index, that is mu. So AM is equal to mu into AC, so that is mu into AC. And as it is upper sideband, it has been divided by 2. In lower sideband, it has also been divided by 2, because the maximum voltage has been divided in equal parts in the upper sideband and the lower sideband. So that has been divided by 2. So there is 2 root 2 here. So AM has to be divided by 2 in the upper sideband and also in the lower sideband, so that the USB power and the LSB power are quite similar to each other, as you can see. Then you can calculate the total power. What the total power is? PT is equal to PC means AC square twice R, that you have get through this. After that, AC square mu square 8R, AC square mu square 8R. Okay, just calculate all of the things. You will finally get this equation, that is PT equals PC minus PC 1 plus mu square by 2. That you have to keep on your mind to calculate the carrier power and the total power out of it. So there are another examples of the power calculation too. The Vrms square, the Vm divided by root 2 whole square. That means the modulating voltage. Here we have used the amplitude and calculate these things.